Hello, this is Mrs. Davis. This is AP Calculus, Unit 7-6, Separable First-Order Differential Equations, figuring out general solutions. Now, we have skipped 7-5. 7-5 is for AP Calc BC. So we're skipping from 7-4 to 7-5, so you didn't miss anything. All right, so it's implicit differentiation backwards, so let's remember to solve these, you have to do implicit differentiation backwards, but let's remind ourselves what implicit differentiation was. So we're going to remember this and take that. So this would be 2x, and we'll do it for dy dx in terms of dy dx, we'll solve for dy dx. So 2x and then plus 2y dy dx, and then the derivative of 9 is 0. So we take the derivative of everything with respect to x. Okay, now then we solved for dy dx. So we say dy dx is negative 2x over 2y. So dy dx came out to be negative x over y. All right, so now separation of variables is like implicit differentiation backwards. So right when I did this, when I put that 2y down there, it's like I put it back. So let's just see, I think it'll make sense. But first, let's just make sure we understand equations where all x terms can be collected with dx and all y terms with dy are said to be separable. So not everything is separable. For now, this is just the one we're using how to solve these types of differential equations. The solution procedure we use is called separation of variables. So it'll have to be in the form f of x times g of y. You have to put it in the form y equals h of x. So you're going to be taking the integral both sides. So now, if it's like f of x plus g of x, you're not going to be able to do it using separation of variables. So these are the kind you can. And so we might be able to factor this one out. We'll see what happens with that. But let's just start doing some. So separation of variables means that you need to have dy and the y's on the left and dx and the x's on the right. That's my little, short way to say what we're doing. So I would multiply both sides by y, so I would get dy times y is equal to 2x dx. So see, there I have it. I have my dy with my y's, and I have my dx with my x's. So probably should say y dy equals 2x dx to have it. Now, we have to show our work, and usually separation of variables gives you 1 point. So what I'm going to do next is write that again and then take the integral of it, because if I took the integral here, if I went like this, because this is what we're going to do, I would lose that point because I don't just show the separation of variables. I'm already starting to integrate. So I know it sounds tedious, but you should rewrite it and then take the integral. So I have the integral of y dy is equal to the integral of 2x dx. So now I am showing that I'm taking the integral. And then the integral of y dy is just y, in terms of y. And the integral of 2x dx would be 2x squared over 2. So that's just x squared plus c. Now, I'm sorry, this would be 1/2, I didn't do that right, 1/2 y squared, right? 1/2 y squared. Now, this has a plus c, and this side has a plus c, but if you were to solve for y, you would get the plus c both places. So watch, I'm going to erase this right here so I have room. Okay, so I'm coming up here to show you that I have 1/2 y squared plus c equals x squared plus c. So then if I want to just add my c or subtract my c over there, I would still just get a plus c. So then I have 1/2. So usually what I'm saying is we just put the c on the right-hand side because you can understand it would be going over there anyway. So 1/2 y squared equals x squared plus c. So then I want to get rid of my 1/2, so I have y squared equals 2x squared plus c. Now I don't write 2c because if you multiply 2 by c, it's still just a c. So it just becomes a c. All right, and then I solve for y explicitly. So y equals plus or minus the square root of 2x squared plus c. Not 2x squared. Yes, isn't it supposed to be 2x squared plus c? I think it is. Did I do something wrong? I think it's 2x. When I took this, that becomes 2x squared over 2, so it's just x squared. Okay, so you could keep it explicit by keeping it y squared and, equals 2x squared plus c, and that's not explicit. Now, we will get to times when we have to choose. If they give us an original point, we've got to choose which one of these plus or minuses we do. But in the meantime, you're just going to write plus or minus the square root of 2x squared plus c. All right, so let's look at b. I don't have an x, but I still have to integrate like a 1, right? So this is like times 1. So I would have y squared, dy, and it's 1 over y squared, right? Because I would have to divide by that, equals dx. So this is actually y to the negative 2 dy equals dx. So this is showing my separation of variables. Then I'm going to take the integral of y to the negative 2 dy equals the integral of dx. So this would be y to the negative 1 over negative 1. So 1 over y equals x plus c. Okay, that was showing taking the antiderivative of each one. And again, we just put the c on the right. Now, this isn't the answer because I need to solve for y. So I would multiply that through by the reciprocal, so I get y equals negative 1 over x plus c. And that would be the answer to that differential equation. Remember, what we're getting is we're getting, using it to solve the differential equation and get a y equals. Just make sure you know what you're doing. Okay, let's look at c. Easy to separate these. This would be 1 over y dy equals x dx. So then that's the 1 point separation of variables. So then do 1 over y dy equals x, integral of x dx. So integral of each side. So the integral of 1 over y is ln of absolute value of y equals 1/2 x squared plus c. So now to get the ln in solve for y, we have to put it in terms of e, right? So this would be e to the 1/2 x squared plus c equals absolute value of y. Now what I'm going to do is important right here. It has to do with what I do with this plus c. First of all, am I going to get a positive number no matter what I do? And so the answer is yes, so I can drop the absolute value. So I'm going to rewrite this. Y equals e to the 1/2 x squared times e to the c. You see how that's the same thing? Because I have this plus there, I'm bringing this back down because that's what that means. I have an e to this and times an e to that. E to, let me highlight, e to 1/2 x squared and an e to c. So this is really important for you to understand why we're doing this. Because what we've done is say we have a constant out times this e to the 1/2 x squared. So this becomes y equals, when we put it out in front, c e to the 1/2 x squared. Because remember, e is not a variable. E to the c is just a c, okay? And so we put it out in front. So we end up with c e to the 1/2 x squared. The c comes out in front when it's an exponential function. So c e to the 1/2 x squared. Okay. All right, let's look at number D, letter D. So they use y prime this time instead of dy dx, but we can still say we have 4y prime is equal to 3e to the x. So that's our separation of variables right there. And so I can divide through by 4 right now. That'd probably be the smartest thing. So I get y prime is equal to 3/4 e to the x. So now I'm going to integrate y prime and integrate 3/4 and then e to the x. So when I integrate y prime, I get 1/2 y squared plus c, right, equals 3/4 e to the x plus c. We're putting the c over there. So now I have to get my y squared and my y and all that. So I'm going to go up here where I have more room. So I'm going to first multiply through by 2. So that would be 6/4, which is 3/2. So y squared is 3/2 e to the x plus c. The c still would be, 3/2 times, 2 times c. So I don't put 2c, I just put c. Once I solve for y, I have to keep my c where it is. Okay, I'm done changing my c. So this is plus or minus, y equals plus or minus the square root of 3/2 e to the x plus c. Okay, again, this is a plus or minus to be, this is implicit and this is explicit way to write it. Now, if I choose this, if I'm doing it explicitly, when they give me initial value and I can solve for c, I will be able to tell you what that is, plus or minus. It will be one or the other, because they're going to give me a function that's going to have a point that's negative or positive, so I'll have to pick one. But for now, that's all we have to do right now. Okay, so now it says find the general solution, which is the same wording, it's just a different way. Find the general solution of the differential equation, and we're going to use separation of variables to do this. So I'm going to say 3y squared dy is equal to x squared plus 1 dx. Then I integrate both sides. I can either keep the 3 there. I'll probably keep the 3 on this side just so it doesn't get mashed up in that. It doesn't really matter, but that would be 3y squared dy equals the integral of x squared plus 1 dx. Take the integral both sides, right? And now this would be the reason, hey, good reason to keep that 3. Look what happens. If I go here and integrate 3y squared, I get 3y cubed over 3, so I end up with y cubed plus c, but we keep the plus c over the other side, equals, and then when I have to integrate x squared plus 1, don't freak out, you just do the x squared and you do the 1, so that would be 1/3 x cubed, 1/3 x cubed plus x plus c. 1/3 x cubed plus x plus c. And so y would be the cube root of 1/3 x cubed plus x plus c. Remember, the cube root doesn't need plus or minus because it just will be what it is. You can have a negative under the cube root. So that would be the answer to example 2. All right, we'll go to the next video.